Hello everyone. Here we're going to be looking at half-life calculation of half-life, or will I say calculations involving half-life. Now, but I'm going to be starting with giving us some formulas that will guide us through. Okay. First of all, half-life is equal to 0.693 all over lambda. Lambda, your T half here is half-life. Your lambda here means decay constant. So in every question, you either be given half-life or you're given decay constant, okay? Now, the amount of substance, okay, another formula here, the amount of substance that remain after decomposition. So after a radioactive substance is decomposed, we can calculate the amount that remain. Now, this amount can be number of atoms, it can be mass, it can be activity, okay? It is equal to N naught into 1 over 2 raised to power T over T half. Now, what does this thing mean? Your N naught here means the original amount. That means the initial amount. Your T is the time of decay. Okay, while T half is the half-life. Okay, so T over T half. Now, but I would also like you to know that T over T half is also what we call number of half-lives. So you can be asked to calculate number of half-lives. It is T over T half. Okay. Now we'll move further from there. Amount of substance that decay, ND. So if you are asked to calculate the amount of substance that decay, it is ND equal to N naught, which is the original amount, minus the amount that remained. That means minus NT. Okay? Another way a question can come out here, you can be asked to calculate or find fraction that remain. Now, how do you know fraction that remain? Just like the formula for amount that remain. But in this case now, you are dealing with just fraction. It's 1 over 2 raised to power T over T half. And the same thing with the fraction that decay. Just subtract this from 1. That will give you the fraction that decay. Okay, so we are going to look at examples now. Here says the half-life of a radioactive substance is 20 years. What is the decay constant? Okay. So we are given half-life, which is T half, to be equal to 20 years, and we're asked to find decay constant. Now, but we already know that half-life is equal to 0.693 divided by the decay constant. So I can make decay constant here a subject of formula. That means lambda is going to be equal to 0.693 all over the half-life, okay? Now, which is going to be 0.693 divided by 20, okay? And that is going to give us 0.03, sorry. That will give us 0.03465, okay, per year. So the unit here, now just know that the unit of decay constant lambda would be inverse of the unit of time. So since my time is given in years, my unit here is per year. Now let's see another question here. Okay, it says this question says the initial number of atoms of a radioactive element is 6.0 times 10 to the power 20 atoms. That's my N naught. 6.0 times 10 to the power 20 atoms. Okay. Now if its half-life is 10 hours, the half-life is 10 hours. Okay, determine the number of atoms which have decayed. We are looking for the number of atoms which have decayed in 30 hours. Our T here is 30 hours. Number of atoms that have decayed, we can call that ND. But remember, we said that number of atoms that have decayed is equal to the original number minus the amount that remained. Okay, so let's find NT, the amount that remained. What is our formula here? Your NT, the amount that remained, is equal to N naught, original amount, into 1 over 2 raised to power T over T half, okay? So if we substitute that here, my original amount is 6.0 times 10 to the power 20, okay, into 1 over 2 multiplied by 30 over, your time is 30, your half-life is 10. Okay, so that will be 6.0 times 10 to the power 20, now multiplied by half times raised to power 3, okay? So that will be 6 times 10 to the power 20, okay? Multiplied by your 1 over 2 raised to power 3 is 1 over 8, okay? So, and that will give us 2, 3 over 4. That means 0.75 times 10 to the power 20 atoms. So this is the amount that remain. But that's not the question. The question is asking us for the amount that decay. And the amount that decay is the original amount. The original amount is 6 times 10 to the power 20 minus the amount that remain. The amount that remain is 0.75 times 10 to the power 20. Okay? If we subtract that, we are going to get 5.25 times 10 to the power 20. Okay? Watch out for more examples. Thank you.